Good everyone, my name is Graphics. Today we want to reproduce the figure that is displayed at the top right corner of the screen, and the figure is a bearing component, and we are told to show the full sectional side view on section AA and also the half sectional top view BB. Now, to give you a clearer view of what I'm talking about, we're having this, right? So he said that what we should show the side view section AA looking at this side, and we should show the top sectional view looking from the top. Now you might be wondering, where can I start in doing this kind of exercise or problem? Now the first thing you have to do is to first of all represent them in an orthographic projection. If you like, you use in third angle projection, and if you like, you use in first angle projection. Now I'll take you down the memory lane where we can draw this. So let's see what will happen. So the first thing to do an orthographic projection is to draw your 4 cardinal points. I'll pick up my set square this way, right? My t-square, and I'm going to draw the horizontal line. You can see that, and I'm going to draw the vertical line also this way. Vertical line also this way. You can see that. That is a vertical line that we have here. So the next thing we have to do is to give the line 5 mm away from these 4 cardinal points, as in you measure, if you like you measure 10, if you like you measure 5, any measurement of your choice, any dimension of your choice. So I'm measuring 5, right? So if I place my 5 here, I'm going to come at this point where they meet. I'm going to mark at the top up, I'll mark here down, I'll mark here, and I'll also come here and I'll mark here. This is what we have. So I'm going to draw my line through this point. So I'll draw it through this point, and I'll also draw it through this point. I'm also going to take this through this point. To this point here, and also through this point here too. Now we've successfully drawn this. This is our point of reference here, where we start our measurement from, this 4 points. So I'm going to clean off here, 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 and here, and I'll be having this. This is what I'm having here. So I'll start taking this drawing, start measuring. Now this is the front elevation of this drawing. So if I draw it above the x-axis, like above the x-axis, it means it's in first angle projection, right? So I can choose any of this quadrant here. So I'll choose here and I'll start measuring. Now if you look at this carefully, the entire length is 96. So we're going to measure 96. So measure 96. This is 96 here. You can see that. This is 96. So I'm starting from 0 here to 96. That's what we have here. So from this point to this point is 96. Now if you look at it closely, the height, the entire height is given us from here to this point here, which is the center point, is given us 42. Now the radius, right, since we are given here to be 24 diameter, so the radius is 12. So we have 42, it's giving us 48, right? From here to here is 48. So we'll say that is 48. So it means the diameter of the circle is 48. So half of it is the radius. So half of 48 is 24. So 24 plus 42, right, will give us 66. Is that taken? So the height of that figure is 66. So I'll come here and I'm going to measure 66. Right? I'll measure 66 as my total. So this is 66 here. At this point. 66. Can you see that? Then I am going to close it up. I'm going to close it up with the help of my rule this way, and close here up also. So this is my entire distance of the figure, the entire height and the entire length, right? So I'll start bringing out this figure out now. First of all, I'll get the half of the figure, or better still, I'll measure from here to here, which is given as what? If you look at it, it's not really given, but if you subtract 72 from 96, you get the distance from here to here and here to here. So let's see. So 72 minus 96 will be 24, right? So it's 24. So if you subtract 72 from 96, we'll have it 24. So it means that from here to here is 12, and from here to here is 12. So from the end in here, which is the end in here, I'm going to measure 12 inward. And from the end in here, which is the end in here, I'll measure 12 inward. So let's measure the 12 and see how that will go. So if I'm measuring the 12 here, this is 12 to this point, right? So I'm going to take in it. I'll come here also. I'll start from 9. I'll measure 12. So this is 9, making up my 0. This is 8. So from here to here is 10, 11, 12. This is 12. So I'll take in it. You can see that. Now we move forward. From here now, the height is 18. So from here, I'll measure 18, which is from here. So measuring 18, I'll come up to this point. I'll measure 18. So this is 10, this is 15, and 18 is just there. All good? It's just there. Then I'll take, if you look at it, it is sticking straight ahead to the end in here. So I'll take my set square and I'll measure, I'll taking it from here, 18 to this point. You can see that. So in doing that, at that point, the next one, I will close up here because here is closed up. So when I'll close it up, I'm going to have what we have here. So closing here up, I'm going to have this from this point to this point, then from this point to this point. You can see that. So from this point now, we have done this to this. So the next thing is the height of here, which is here, is given as 6. So I'll measure 6 at both sides. So I'll just take my set square and project it upward a little bit. I'll come here also, project it upward a little bit. You can see that. Then I'll now measure the 6. So measuring the 6 from here, from the ground floor here, I'll measure 6. So this is 10, this is 5, and this is what? This is 6 here. So I can just stick in it from here to this point because there is a 6. Stop here. Then I'll connect it straight ahead, just trying to replicate what I have there. I'll connect it straight ahead, right? Then close it up. We're just trying to replicate what we have at the top right corner of the screen, which is this, right? So we successfully drawn out all this down. Now it's remaining this top here. So what I'm going to do is I'm now going to measure 42. 42 will take me to the center of the circle, center of this figure here, as in, so I measure 42. So from here, the base here, I'm going to measure 42. From here to here is 42, right? This is 30, 40, 41, 42. You can see that? 40, 41, 42 at this point here. So I'll just use faint line to just, or center line if possible, center line. So I'll just draw it out. So that is where it is situated. So from that point, I need to get the center of this figure. So half of 96, because from here to here is 96. So half of 96 will be 48. So I'm going to measure 48. So if you look at this from here, from this point to this point, it's giving us 96, right? So if I move 40 and 48 will be here. 48 will be here. Can you see that? So I'm going to use my meter rule. Now draw another center line there to show that is the center of the figure, because it's a symmetrical object. So at this point, I'm going to measure the center line, the long, short, long, short, long, short. You can see that? Let's put this way. So this is where they are meeting here. So from that point, if you look at this figure very well, I have successfully drawn this and this, right? So from this point, this bigger circle is supposed to be written this way. The arrow is supposed to be on this, right? The diameter. From here, the distance from here to here is what? 48. So I'm going to take half of 48, which will be 24. The radius is 24, so I will change this man here to be giving us what? Radius 24. So this is radius here, not diameter. So here is radius 24. So the diameter here is diameter 48. Is that taken? So half of 48, the radius is 24. So I'll take radius 24 on my meter rule. 24, this 20 and 24 is here. And I'll place it at the center here, right? And I'm going to just draw my semicircle. See, automatically it's touching the roof here, shows it that is the entire, because it took the entire distance. This is what we have here, right? Now if you watch this closely, from this point you draw a straight line that is connecting to this. So I'll take my set square and t square from this point. I'm going to join it downward to here. Then from this point, I'm going to join it downward here to this point. Now I've produced this, so it's remaining the inner one here, and the inner one is giving us if you look closely, we are giving the inner one to be 24, right? So the actual thing is this inner diameter here, the inner diameter here, they're giving us what? They're giving us diameter 24. Why the radius of this circle here is given as what? As 24. So this is for this, why this is for this. So with the radius of 24, with the radius of 12, I'll measure it on my meter rule, right? I'll measure my meter rule 12. It's 12 here. Then I'll come here and I'm going to draw the circle there. This is what we have here, right? So what they're actually trying to do here is to tell us that the um the diameter of here, look at what I should do my I will having this to be given as what, radius 24, radius what, 24, right? And this to be given us diameter 24. So that is what they were actually trying to show you here, right? So we successfully brought out the shape. That is our aim and objective. Successfully, if you look, brought out the shape. Now the next thing we need to draw is the plan. The plan is always under the elevation, right? So I'm going to project it downward. So first of all, draw out all the elevations first. So if I come here, I'll project this downward this way, right? If I come here, I'll project this downward this way. If I come here, I'll project this downward this way. And the center of the circle also downward this way. All edges, all the edges, I'll project them down. Right, so here, here, here. Now look at what we just did. Now if you look at the diagram, we're only given the length and the height. Like I told you, your front elevation is always having the length and the height, right? We're not given the width of the we're not given the width of the plan. So what I'll just do is I'll just use a smaller distance, which will be 48, right? Why am I using 48? I'm only just using half of this distance, right? So the width here will be what, 48. So I should just measure the 48 here. From here to here is 48. Right? This point is 48. So I'm going to close it up with a straight line, which I'm going to just take in. And I'll close it up to the straight line here, because the width, the length of the elevation and the length of the plan is the same. So like I was saying in my previous video, that the elevation has to deal with the height and the length, but the plan will deal with the length and the width. So this is the length and the width, right? And this is what we have here. Now if you look at this now, if I in here is telling me that it is there's a line here, right? So I'll tick in it. But if you look at it closely here, you cannot see it when you're looking at it from the top. It will be shown as what, a hidden line, right? To be shown as a hidden line. So that's why I'm going to use hidden line to represent it. So I'll use the hidden line here to represent it. So one long, one short, one long, one short, and so on. Then short, short, all through, equally distributed. Then I'll come here also, I'll do the same thing here also. This is what we have here. Right? Now, from here, it shows that if you're looking at it from the top, there's a true in this circle, right? So you cannot see it in. So to show it on my plan, I told you when you're looking at the plan perpendicularly, you see any circular object as a straight line. So on the plan, the circular object will be in form of a straight line. So I'm going to just show my hidden line here. Then I'll come here also. I'll show my hidden line here. Now this is what we have here, right? Now if you look at this, looking from the top will be in form of a straight line here. This will be a straight line this way, and this will be a straight line this way. So we've successfully drawn out the plan, right? We have done what? We've drawn out the plan. Now the next thing we have to do is to bring out the end view, right? I told you the elevation is the center of attraction. Every other thing is connected to it, both the end view and the plan. So if I should want to draw this to connect to this, I must draw my perpendicular, my 45-degree here. So I'll just connect here and here together, or I'll bisect it, but this is easier and faster. I'll just draw it this way. So I'll connect this to this point here. I'll connect it to that point. So I'll come up here, and I'm going to project this line from here outward here, so other things will start flowing up. So this is the only connection we have with this and this here, so I'll just take them up. Right, so from here I'll start joining all these points together, this to this, this to this, then this to this, then this to this, this to this, and we're already join all those points together. Now looking at it from the other side, as in from this side here, right, you will see the end view, and the end view will just be this. This is what I have here to this point, right? Then the next thing that I have here also is to this point. Sorry. At this point, so I'll close it up here. So if you look at this now, looking at it from here, you will not see the circle in. So that will be hidden line this way. And this will be another hidden line this way. And this, you can see this looking at it from here, because it is to show that there's something inside here that is a straight line. So if you trace it, I'll just draw it this way. Then this will just be a straight line this way. I can see it. Now this is what we have. And normally this is the elevation, this is the plan, and this is the NV. And you may be wondering, where did this come from? No, let me assemble this, so I'll give you a better explanation on how we go about this, right? So just see, I'll do it just close to this place. So I'll move it there. So I'll be doing it at that point. See that? So I'll just draw it here so you see what I'm talking about. Now, to give you a better understanding, actually, if we are told to just draw in orthographic projection to complete the elevations of that drawing, this is my answer here, right? But we're not told that it is sectioned. So to give you a better insight, if you look at it here, we are told that what? It is sectioned. That we need to cut this thing into half. When we cut into half, what will be the end view? When we cut it here, what will be the plan? So to give you a better insight, I will draw the isometric drawing of it in full, right? And when it is cut at both sides. Now let's see that. And I'll close it up. You can see that. So this is the entire figure that we have here. This is what is this. Is that taken? Now I will draw this by sectioning this thing into two. So I want to replicate this by what? Sectioning them. Is that taken? So if I section them, I want you to put this into notice. Before I want to section them, without being told whatever you are given, without sectioning, this is what we have here. Now if we section, I will see section this figure here, right? So let me just give you a picture of this. Now if you look, I have replicated this drawing here. Now we want to start. If you look at the diagram here closely, we are told that this figure is sectioned. If you look for the figure AA, that is what? That is section. So you look at the arrow is facing this side. So that means we are looking at it from this side. Is that taken? So we want to see that the section view of this side. You see what will happen. So if I section here, look at what they said, cut it into half. I want to cut that diagram into half. That is where it is interesting. So let me cut it into half. Now if I take my set square, I place it this way from this center point here, right? And I section it like this. They want me to section it, right? Looking at this arrow here. This is my arrow facing here. AA. Right? So I will section here too and make it a bit bolder so you can see this. I'm sectioning here. That is my cutting plane. And it's coming down here too. My cutting plane. So now we're looking at this direction, don't forget that. This direction. Yeah. That is what? AA. So we're looking at it at this direction. Are we good? So if we section it, it means that all these parts will be remaining. So let's see. Now since we've done that, it will be you see that there's still a true, so all the hidden line will become what? Thick line. Then you section. So I want to implement this here now. So this line, instead of writing my hidden line, I'm going to draw this way. And I'm going to draw this way. Then I will now section it using my 45-degree set square. Section those two parts to expose the guy out. So this will be sectioned. So all the hidden line will become thick lines. So the sectioning usually expose hidden features. To expose them. So I'm using the front line. Come here also. I'll do the same thing. Right? Now you can see I've sectioned it. That again, section. Now we're going to section here too because of there's a hidden feature. So what I will section is I will make here to be visible this way, right? then I'll section it in the other way round like this. So since it's coming like this, then this will be coming like this to show that it's a different component entirely. So all the hidden line will become visible. Right? So this is what we have in here. So the true here is the hole here that's saying that what nothing is passing through there. Is that taken? So this is the solution of what we are asked. I just went further to explain this to you. What you are told to draw at the beginning of the class is this. So this is how we come about this. Now the next thing is we are told to section the plan. Now we've already sectioned here, we have cut here off. Now we want to now section the plan. So the same thing will happen. So I'll be using this my figure to show you what actually is really happening here. Just this one here. So let's see what will happen. Now if we section this from the diagram that I said so far, it says that we should section it from the center of the circle and looking down. So look at what will happen. If I section it from the center of the circle, I'll be having something like this. So this is the half of the circle here. So you say we should section it this way. So we should section it this way, right? So we should section here off. This, right? Okay, so we section it off. I can actually complete this to be like this. So my plane will be like this. It will be like this. BB. This is what they want us to do. You're gonna take from here. Sorry, from the top. You see that? So not this. Now this is BB here. So we're looking at it from the top after we've sectioned it. So what we'll do is this. Looking at it from the top. So I'll come here. This don't you see? If I come here, it means that this hidden line will become a thick line. Right? This will become a thick line. Then will become a thick line this way. And here also a thick line this way. And I'll now section it using my 45-degree set square. Just section here where we cut. So this will be 45, 45. So this is the answer to what we thought to do. So this is the plan, looking at it from the top of it, right? BB, this is what they mean by what? BB, and this is what they mean by what? AA. So this is what, from the beginning of the question, this is what they are told to do. So I just went ahead to give you an insight of what they're actually talking about. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.